Do you know how to describe the relationship between voltage, current, and resistance? Let us find out in today's episode. Welcome back, my dear learners! For today's lesson, we will discuss one of the interesting topics in electronics. I am Mr. John Lexor Emperador, your subject teacher for today's session. At the end of our discussion, you, as a learner, are expected to first, identify the formula of Ohm's law. Second, perform the mathematical problem using Ohm's law. And lastly, appreciate the importance of Ohm's law. Before we begin our lesson, let us recall what we had discussed in our previous discussion. I'm going to ask few questions with regards to our previous lesson about the current, voltage, resistance, and circuits. Each question have 5 seconds to answer. So are you class ready? Let's start. Question number 1. What is the unit of current? That is ampere. Question number 2. What is the unit of voltage? That is volt. Question number 3. What is the unit of resistance? That is ohm. Question number 4. What kind of circuit is this? That is parallel circuit. Question number 5. What kind of circuit is this? That is series circuit. Okay, so that is the recap of our previous lesson. So have you answered it all correctly? That's good. So now, get a piece of paper and pen and answer your first activity. So for your activity, you are tasked to interpret the meaning of the statement by deriving a formula or making a pyramid form to simply illustrate your understanding. I will give you 60 seconds to do this. Is that clear? Alright, so without further ado, let's get started. Now, let us analyze the given statement in your activity. Let us read. The current in a circuit is directly proportional to the total voltage acting in the circuit and inversely proportional to the total resistance of the circuit. The meaning of the current in a circuit is directly proportional to the total voltage acting in the circuit is when the current increases, the voltage also increases. And when the current decreases, the voltage also decreases. Therefore, the current and voltage is equal to each other. However, the meaning of the next statement, that the current is inversely proportional to the total resistance of the circuit, is when the current increases, the resistance decreases. And when the current decreases, the resistance increases. Therefore, the current and resistance is not equal to each other. Having that said, when we combine the whole interpretation of the statement, we can sum it up into like this. Is your answer the same to our explanation? If not, that's okay, because that will be our lesson for today. However, if you got the same idea, then I'm pretty sure that you are advanced in this lesson or your comprehension is exceptional. Now let's move on. From whom did this statement come? Do you have any idea? Statement that the current is directly proportional to the total voltage in the circuit and inversely proportional to the resistance is under the statement of Ohm's law. The Ohm's law was theorized by George Simon Ohm, a German scientist. The relationship of voltage, current, and resistance is algebraically derived using this formula, where E is the voltage in volts, R is the resistance in ohms, and I is the current in amperes. So R is equals to E over I, then I is equals to E over R, and E is equals to I times R. Now, let us discuss how to apply the Ohm's law in series and parallel circuits. Let us take a look in this series circuit. The total voltage is equal to the summation of individual voltages, while the total current is equally distributed throughout the circuit. If you want to get the value of individual voltages in series circuit, you must simply multiply the value of total current to the value of individual resistance. In parallel circuits, the total voltage is equal to the value of individual voltages, while the total current is the summation of the individual current. For you to easily remember this, just be mindful that the principle of current and voltage in parallel circuit is opposite in series circuit. If you want to get the value of individual current, divide the total voltage over the value of individual resistance. Let us have our first example. Find the current in the given circuit diagram. The first thing that you need to do is to write the given value for you to solve easily the given problem. The value of total voltage is 12 volts, while the resistance is 1000 ohms or 1 kilo ohms. So the problem is to find the value of I or current. So the formula to get this problem is I is equals to E over R. So transfer the given value to the given formula, then the final answer is 0.012 ampere. Okay, next, example number 2. So find the resistance in the given circuit diagram. So the givens are 24 volts, 1.5 ampere, 3.4 ohms in resistor 1, and 6.2 ohms in resistor 3. So the problem here is to find the resistance value of R2. So the formula to get the R2 is equal to the individual value of voltage divided by the total current in the series circuit. However, we cannot proceed to solve this because the value of E2 is undetermined. Therefore, we have to solve the value of individual voltages. In order to do that, let us solve the E1. E1 is equal to the current multiplied to resistance of R1. So transfer and solve the given value. The answer is 5.1 volts. For E3, multiply the total current to resistance of R3. Transfer and solve the value. Then the answer is 9.3 volts. So since the total voltages is equal to the summation of individual voltages, we have to transfer their given values. And then, transpose the E2, and the answer now is 9.6 volts. So here, we can calculate the resistance value of R2. So transfer and solve the given values, then the final answer is 6.4 ohms. Next, for example number 3, so a 30 ohm resistance is connected in parallel with a resistor whose ohmic value is unknown. So if the total current is 5.7 ampere, when the circuit is 114 volts, calculate the unknown resistance of R2. So the givens here are 114 volts, the 30 ohms for R1, and 5.7 ampere. So in order to get the value of R2, so the R2 is equals to total voltage divided by individual value of current in parallel circuit. However, the value of I2 is unknown in the circuit, so we have to get the value of individual currents. So in order to do that, so let us solve the individual currents. So since the total values are given in voltage and resistance, so we have to transfer their given values to the formula of total current, and then we can come up to the answer of 3.8 amperes. So since the total current is equal to the summation of individual current in parallel circuit, so we have to transfer their given values and then transpose the I2, and the answer is 1.9 amperes. So at this moment, we can now calculate the resistance value of R2. So transfer and solve the values for this formula, then the final answer is 60 ohms. Okay class, so that is our lesson about Ohm's law. Do you understand how to get the unknown value of current, voltage, and resistance? That's great! So at this moment, let us check your full understanding about our lesson. Direction. Solve the given problem in the series and parallel circuits using Ohm's law. The time limit to solve this problem is 2 minutes. And that is the end of our discussion for today. I hope that you understand our lesson very well. If not, you may watch again this episode until you fully appreciate our lesson. By the way, don't forget to like, share, subscribe, and hit the notification bell for more updates of our new lesson. So see you guys in our next episode. Bye!